Hey guys, welcome to another video. In this video, we're going to be exploring two different FRQ questions from Unit 1. So let's start. The first question over here, they showed me a graph of f and the table for g. They told me that f has a discontinuity due to a vertical asymptote at x is equal to 6. And they told me that g is a continuous function for all x. Values of g are selected at selected values of x are shown in the table above. The first question, they said, using the graph of f and the table for g, estimate limit as x is going to 0 for f of x minus g of x. So, limit as x is going to 0 for f of x minus g of x is going to be the same as limit as x tends to 0 for f of x minus the limit as x is going to 0 for g of x. So if we go to the graph of f, at 0, it was basically equal to 2. And if you're going to go to the table for g, these two values are the closest numbers to 0, which means that it's also going to 2. So it was going to be 2 minus 2, which will result in 0. And this is it for part A. For part B, they told me to find the limit at these respective points, and we need to explain why a limit does not exist, if it does not exist. So, limit as x is going to 1 f of x. So if you go to the function of f, the graph of f, we notice at x is equal to 1, we have two different limits at 1. So at 1 minus it's basically 1, and at 1 plus it's basically 0. So we're going to say that limit as x tends to 1 f of x does not exist because limit as x is going to 1 minus f of x which is equal to 1, is different from 0, which is equal to the limit as x tends to 1 plus f of x. Now, obviously, you could say it in a much more separated, simplified manner, like you can say, because limit as x tends to 1 minus f of x is equal to 1, and limit as x tends to 1 plus f of x is equal to 0. So they are different. Okay? The second one, limit as x is going to 2 f of x. Go back to the graph again. At x is equal to 2, from the left and from the right, we could see that the function is approaching the value of 1. So this is equal to 1. Limit as x tends to 4 f of x. We go back over here. At 4, we notice that both the function from the right and from the left, it's approaching -1. And the last one, which is limit as x is going to 6 f of x. So at x is going to 6, we notice that from 6 minus it's going to positive infinity, and from 6 plus it's going to positive infinity. So since it's going to the same exact value from both sides, that means limit as x is going to 6 for f of x is indeed positive infinity. So let's just write a small explanation over here, even though that we don't need to because it exists after all. So just more details will never hurt. Now, part C. Is there anything that we missed? No, that's it. Part C. Is f continuous at x is equal to -3? So using correct notation, of course, justify your answer. Now, if I'm going to look at -3 over here, -3 is right over here. So even though that the limit is basically equal to -1, because from both sides of the limit, it's approaching -1. However, when x is equal to -3 exactly, f of -3 is going to be 2, which will result in a discontinuity. So basically, we're going to say that, no, at x is equal to -3, f of x is not continuous because even though limit as x is going to -3 minus f of x is equal to limit as x is going to -3 plus f of x, which is basically equal to -1, f of -3 is 2, which is different than -1. Therefore, f of x is not continuous. Last question, they told me to write a difference quotient that best approximates the instantaneous rate of change of g at x is equal to 0. So at x is equal to 0, we're going to use the table for g in order to write the instantaneous rate of change. The closest two numbers for 0 are basically these two over here. So the instantaneous rate of change, we're going to call it g prime of x. Did they say at 0, right? So g prime of 0, it is basically going to be g of 0.001 minus g of negative 0.001 over 0.001 minus 0.001. So over here, they just told me the difference quotient, a difference quotient that best approximates the instantaneous rate of change. So you don't need to find the answer over here, just the expression itself. So yeah, that's it for part D. The second question over here, they gave me a function which numerator is a polynomial. So f of x is ax squared plus bx plus 2 over 2x squared minus 8. So the first piece of information they gave me, they said that we have a horizontal asymptote at y is equal to 3, and f has a removable discontinuity at x is equal to 2. Which brings us to the first question, show that a is equal to 6, b is equal to -13. So since y is equal to 3 is a horizontal asymptote, it means that limit as x is going to infinity for f of x is going to be equal to 3. Which means that limit as x is going to infinity, since x is going to infinity, that means I can put the highest power in the numerator over the highest power in the denominator, and I can neglect anything else. Because when you're going to infinity, one slight change makes something so much bigger than the other, which means that ax squared and 2x squared are substantially bigger than anything else in the whole function. So ax squared over 2x squared is supposed to be equal to 3. Now, by simplifying x squared from both sides, I find out that a over 2 is equal to 3. Which means that a is equal to 6. Now, according to the second piece of information, they said that x is equal to 2 is a removable discontinuity. Now, what I'm going to do, I'm going to try to simplify the denominator so I can see this piece of information clearly. So by taking 2 as a common factor, I will get x squared minus 4. And x squared minus 4 is basically a remarkable identity that says a squared minus b squared is a minus b, a plus b. So if x is equal to 2 is a removable discontinuity, that means x minus 2 is a factor over here, which also means that x is equal to 2 is a root. Now let's remind ourselves, what does root mean? It means simply, if I replace x with 2, and put the x as 2 over here, my answer is supposed to be 0. So, since x is equal to 2 is a removable discontinuity, just a minor explanation will never hurt, then x is equal to 2 is a root for 6x squared plus bx plus 2, which means that 2 to the power of 2 plus b times 2 plus 2 is equal to 0. So 2 to the power of 2 is going to be 4 times 6, which is 24, plus 2b plus 2 is equal to 0. Now 24 plus 2 is going to be 26. Take it to the other side, and now you have 2b is equal to minus 26, divided by 2 from both sides, and finally you will have b equals minus 13. So that's it for part A. Part B. To make f continuous at x is equal to 2, f of 2 should be defined as what value? Justify your answer. Now this is a very interesting question, because in order to make f continuous, f of 2 should be equal to the limit as x is going to 2 f of x. So basically we need to find limit as x is going to 2, and automatically I will know the value of f of 2, what should it be? So limit as x tends to 2 for f of x is the same as saying limit as x is going to 2 for 6x squared minus 13x plus 2 over 2x minus 2 x plus 2. Now, first things first, make sure that you take the 6 as a common factor in the numerator first, because people tend to make the mistake when they are doing mode 5.3 on the calculator, scientific calculator, they would forget that 6 is the first coefficient, so it never disappears. So you have to write it as x squared minus 13 over 6 x plus 2 over 6 over 2 into x minus 2 x plus 2. So now, using a scientific calculator, we can find. All right, let me just find my calculator with me. Okay, so A is 1, B is negative 13 over 6, and C is basically 2 over 6. Calculate. We get that x is equal to 2. So equals limit as x is going to 2 for 6. X is equal to 2, so x minus 2. Or x is equal to 1 over 6. So x minus 1 over 6. All of it is over 2 x minus 2, x plus 2. So now x minus 2 and x minus 2 are going to go, and then I can just replace x with 2. So I'm going to have 6, 2 minus 1 over 6. All of it is over 2 multiplied by 2 plus 2. Now 6 divided by 2 over here is going to be 3. So it will be 3. 2 minus 1 over 6 is going to be 11 over 6, and down it's going to be 4. 6 divided by 2, okay, just for me to know that. Okay, so now 3 times 11 is going to be 33, and 6 is going to go down, so 6 times 4 is 24. So the answer over here is going to be 33 over 24. So in order for f of x to be continuous at x is equal to 2, I need to have that f of 2 is equal to the limit as x is going to 2 f of x, which is 33 over 24. Small explanation goes a very long way. Part C. At what value of x does f have a discontinuity due to a vertical asymptote? Give a reason for your answer. So over here, usually, well, not usually, almost always, the denominator that cannot be crossed with something with the numerator is the vertical asymptote. In this case, it's going to be my x plus 2. So basically, x is equal to negative 2 is a vertical asymptote. Because two dots, limit as x is going to -2 minus f of x is going to be 6. I'm going to consider as x minus 2 already gone. So -2, -1 over 6 over 2 times -2 minus +2. Now, -2 minus +2 is going to be 0 minus. So 0 minus times 2 is still going, or like 6 divided by 2, you're going to get 3 on top. Whatever you get on top, it doesn't matter, because what happens below is basically 0 minus, which is going to result with -infinity. And similarly, limit as x tends to -2 plus f of x is going to result with +infinity. Therefore, x is equal to -2 is a vertical asymptote. So to answer their question, at what value of x does f have a discontinuity due to a vertical asymptote? It's at x is equal to -2. Thank you for watching, and be sure to watch the other video.